Welcome back, dear students, to the part 2 of this lesson, which we discussed about concerns and factors of critical value. This part consisting of discussing critical values with more detail. For both testing of hypothesis and getting the confidence intervals, critical values account for uncertainty in sample data that is used in making inference about a population. Critical values will help us in addressing the concerns of how does the sample estimate need to be statistically significant from the null hypothesis, what is the margin of error, that is confidence interval, around the sample estimate of the population parameter. Concerns that what with critical values for testing of hypothesis are: usually the sampling distribution of the related test statistic will define the range of probability values. The level of significance, usually denoted with alpha, specifies the probability that corresponds with the critical value within the distribution. Critical value depends on the significance level and whether they are performing a one-side test hypothesis or a two-sided test hypothesis. If you consider 0.05 as the significance level, then it defines how improbable the test statistic must be significant. Concerns continues with an examples of Z test. It uses the Z statistic for which standard normal sampling distribution finds the G score range with an assumption that the null hypothesis is true. For a G test, the null G score is 0, which is the mean of standard normal distribution. This standard normal sampling distribution centers on the null hypothesis value, and the critical value marks the minimum distance from the null hypothesis required for statistical significance. Factors that decide the critical values. There are several factors which we have to consider for computing or arriving to the value called critical value. First one is degrees of freedom of the test statistics which the sampling distribution of the parent population. The number of independent pieces of information used to calculate a statistic. It is calculated as the sample size minus the number of restrictions. Second factor is level of significance. The fixed probability of wrong examination of the null hypothesis when it is true. The fifth factor is the researcher presents the probability of type 1 error with the outcome of the error. The sixth factor, we consider that the statistics sampling distribution of the parent population for testing the null hypothesis with standard normal distribution and also with chi-square distribution. So, this shows that these are the two distributions having two shapes of frequency curves. If you say that left hand side is depicting the shape of standard normal distribution and the right hand side picture depicting the shape of chi-square distribution. Interestingly, the critical values are existing to the right hand side. Seventh factor of the deciding the critical values is that the statistics sampling distribution of the parent population for testing the null hypothesis with Snedeker's F distribution, which is the left side part, students T distribution, which is in the right hand side. The right hand side depicting probability distribution, which speaks about the similar formalities or properties of sampling distribution with standard normal distribution, whereas the F distribution is positively skewed distribution. And coming to the eighth factor, which is nature of the alternative hypothesis and type of the test, which are always matter for computing the critical values. There are three possible cases when you can have right tail test, left tail test and both tail tests. So, coming to the role of p value in testing of hypothesis, meaning wise p value is playing a very important role. This is defined as the probability under the assumption of no effect or no difference. No difference usually addressed by null hypothesis, of obtaining a result equal to or more extreme than what was observed. The P stands for probability and measures how likely it is that any observed differences between groups is due to chance. Understanding the p value further, the p value is a number which calculated from a statistical test that describes how likely you are to have found a particular set of observation if the null hypothesis were true. P value is used in hypothesis testing to decide whether to reject the null hypothesis. The smaller p value, the more likely you are to reject the null hypothesis. What exactly p value is meant for? The p value or probability value tells us likely it is that the data could occur under the null hypothesis. It does this by calculating the likelihood of the test statistic, which is the number calculated by statistic test using the given data. The p value tells you how often you will expect to see a test statistic as extreme or more extreme than the one calculated by your statistical test if the null hypothesis of the test is true. The p value gets smaller as the test statistic calculated from your data gets further away from the range of test statistics predicted by the null hypothesis. Coming to the relevance of p value in testing of hypothesis. When any test we consider hypothesis is tested, we end up with an associated p value, again the probability of the observed sample statistic if the null hypothesis is true. We compare the p value to the pre-selected significance level alpha. If p is less than or equal to alpha, the results are statistically significant and therefore generalizable to the population. Students, let us summarize the part 2 of the lesson. In this lesson, we have detailed discuss on what the critical value and how it is useful in testing of hypothesis. We also discussed how to calculate the critical value with the examples of g-test. Further, we also discussed about the p value in more detailed way and also with the factors that are deciding the critical values. Dear students, I hope you understand all the concepts in the part 2 of the lesson in detailed way. These concepts are very much useful in the research methodology, particularly psychological research methods. We will continue in the next video. Thank you.